Hello students, in today's class we will see what is a transfer function and how to derive a transfer function for a system. How do you define a transfer function? A transfer function is defined as Laplace transform of output divided by Laplace transform of input. It is the ratio of Laplace transform of output to Laplace transform of input at zero initial conditions. See, this is must, okay. Mostly we can find students not writing this one, zero initial conditions, but it has to be written, right? For example, let us, T of S is a transfer function. So transfer function is nothing but ratio of Laplace transform of output to the Laplace transform of input at zero initial conditions. Okay, we know the mass spring damper system, right? We know the differential equation governing the mass spring damper system. What is it? It is nothing but f of t is equal to m d square x by dt square plus b dx by dt plus k x of t, right? When we want to write a transfer function for this differential equation, then you have to find out the Laplace transform for this differential equation. What will be the Laplace transform? So when you take the Laplace transform of f of t, it will become f of s. See, if it is f of t, in terms of time, it is small f. When you write it in terms of Laplace, it is capital F, okay. So f of s is equal to m d square x by dt square. See, when you don't use this zero initial conditions, what will happen? For example, you take this dx by dt. When you want to find the Laplace transform of this, it is nothing but s x of s minus x of 0, okay. But in transfer function, you will have only this x of s and this will be ignored, okay. So only we need to write this zero initial conditions. So when you apply it to this equation, what happens? It is m s square x of s, but actually second derivative d square x by dt square is nothing but s square x of s minus s x of 0 minus x of 0, okay. But we are ignoring those terms because zero initial conditions, okay, plus b s x of s. Here also we are ignoring that minus x of 0 term because of zero initial conditions. Then plus k x of s, okay. F of s is the input and displacement is the output. Force is the input and displacement is the output. Now, the next step can be written as this x of s. Displacement is common, so take it out. M s square plus bs plus k, right? And finally, the transfer function is, what is the output? X of s. What is the input? F of s. And when zero initial conditions are applied, it is nothing but so this is the transfer function for a simple mass spring damper system.